Now, let's do another question. In this question, we are told that PQRS are points on the circumference, and we are also told that PQ and RS are produced to meter T. A. They say we must prove that TP times TQ is equals to TS times TR. Now, since we are told that we must show that TP times TQ is equals to TS times TR. You can see that TP is in this triangle. You can see that TQ is in this triangle. You can see that TS is also in this small triangle, and TR is in this triangle there. Therefore, for us to prove this, we know we must prove similarity of triangles. Therefore, it means that we must prove that this triangle is similar to this triangle. Once we have proved that this triangle is similar to this triangle, then we can set up our ratios, then prove that. So let's first prove that the two triangles are similar. In triangle TPS and triangle TQR. Now, in triangle TPS and triangle TQR, we can assume that this is parallel to that. Now, before we can even prove that the two triangles are similar, we must not forget, we must eliminate all the theorems which are not there. Since we don't have a center, theorem number 1 and theorem number 2 out. Since we don't have a diameter, theorem number 3 out. We don't have angles at the same segment, theorem number 4 out. Theorem number 5, since PQRS are points on the circumference, it means that PQRS is a cyclic quad. Therefore, we do have theorem number 5, T5, but we don't know whether we're going to use it or not. We will see. We do have an exterior angle of a cyclic quad, so we do have theorem number 6 here. Therefore, theorem number 5 and 6 are here. We don't have tangents, so theorem number 7, 8, 9 are not here. So we only have theorem number 5 and 6. Therefore, in triangle TPS and triangle TQR, now we're proving similarity. T angle PS, which is this angle there, obviously in this triangle, this angle is equals to this angle there in this triangle is equals to angle R. Why is that? Because this is an exterior, theorem number 6. This is an exterior angle of a cyclic quad, which is equals to the opposite interior angle. Therefore, this angle is equals to that angle. Reason, exterior angle of cyclic quad is equals to opposite interior angle. Exterior angle of cyclic quadrilateral is equals to the opposite interior angle. Now, also, this angle there is equals to this angle there. P angle S P is equals to angle Q. Reason? Same reason. Exterior angle of cyclic quad is equals to the opposite interior angle. Now, angle T is equals to angle T, because angle T is common for the two triangles. It's still an angle for this triangle. It's still an angle for this triangle. Therefore, angle T is common. Therefore, triangle TPS is similar to triangle TQR. Now, why are we saying that they are similar? We know the two triangles are equiangular. Equiangular triangles. Now, since this triangle is similar to this triangle, we can highlight angles which are equal. In this triangle, just going to use green. And this triangle, this angle, we said it that it is equals to this angle and the bigger triangle. We've also said that this angle is equals to this angle in the bigger triangle. And we know that T is common. We also know that T is common. Now, we are told to prove, so we have proved similarity. Now we can prove our A. Obviously, A starts here. Therefore, now we can prove that. We set up our ratio. Since they talk about TP, and TP is opposite this angle and this triangle. TR is opposite this angle and this triangle. Then we can say TP over TR is equals to, now we've talked about TS. TS is opposite this angle there in this triangle. But obviously, we need to see where did we start. We started at TP. So it means that we started in this triangle over in this triangle TR. We still need to start in the small triangle where obviously we are told about TS, and TS is opposite this angle. Therefore, it means that we're going to have TS over, obviously, TS is opposite that. So this angle here is opposite this side here, which is TQ. TQ. Now, we can cross multiply. This multiplied by this is TP, TQ, which is equals to this multiplied by that, which is TS times TR, which we have proved. Therefore, we must always, when we are given to prove this, look at your sides, then check which triangles must we solve or must we prove to be similar. Then after proving to be similar, then we can prove that what they are looking for. Now, B, they say to us, hence, when they say hence, it means that we must continue from what we have done on A. Hence, prove that PQ is equals to TR times TS minus TP squared over TP. As I've just said it, when they say hence, prove that. So from that, we're gonna hence continue to prove PQ from what we have proved there. That's what they mean by hence. We're proving from what we're given there. Now, since this is continuation, I'd love to cancel, to erase this. For us to get B, PQ, we can see PQ is this length here. But now, there's no PQ here. But there is TQ here. And TQ, there's TQ. So there is TQ. So from TQ, we can get TP. TQ, that's what we have, okay? TQ is equals to this plus that will give TQ. TQ is equals to TP plus TQ. We're getting the whole of this. If I add this length and this length, I get the whole of this length. Therefore, TQ is equals to TP plus PQ. Okay? Now, it means we can go there and substitute this where we see TQ. TP times our TQ is TP plus PQ, which is equals to TS times TR. Now, we can open brackets because brackets in mathematics means that we are multiplying. Therefore, this multiplied by that is TP squared. This multiplied by that plus TP times PQ, which is equals to TS times TR. Now, I want PQ. I must take TP to the other side of the equal sign. It's going to become minus. Therefore, TP times times TQ is equals to TS times TR minus TP squared. PQ, sorry, this is PQ here. Because TP times PQ, we took this to the other side of the equal sign. That is why it becomes TS times TR minus TP squared. Now, I'm looking for PQ. I divide by TP. Therefore, obviously, this will cancel. I'm going to be left with PQ is equals to TS dot TR minus TP squared. I'm just going to divide there over TP, which is what we have proved there. Now, B, done. This is how we go about proving B. C, they said to us we must calculate X if PQ PQ, they say it's X. TP, they say it's X plus 2. That's TP, X plus 2. SR is 2 times PQ. But we know what is PQ. PQ is X. Therefore, SR is 2 times X because it's 2 times PQ, SR. Now our TS is 4. Now, since we do have that, and we do have PQ, which is X, we are running in short of TR. We don't know TR because we do have TS, which is 4. We do have TP. TP is X plus 2. We do have TP, which is X plus 2. The only thing that we don't have here is TR. And we can find TR. Now when I'm doing C, I can remove this part here. Now, TR, I must first find TR because the rest of these we do have. Now, TR is equals to TS plus SR. What is TS? TS you are given, it is 4, plus what is SR? We've just said it, but it is 2x. Now, we can substitute what we are given there, here. What is PQ? PQ is X. X is equals to, what is TR? TR is 4 plus 2x times, what is TS? TS is 4, you can see, minus, there's a minus there. What is TP? TP, it's X plus 2, so the minus, this is TP, it must be all squared. TP is all squared, you can see. And our TP is given by X plus 2. Our TP, X plus 2. There's your TP, X plus 2. But since it is squared, we are squaring it. Over our TP, obviously, it's still X plus 2. X plus 2. Now you have seen this in algebra. I know algebra is one of the simplest part in mathematics, but sometimes it becomes hard for students. We have seen this in algebra. I can see that there's X plus 2 there. There is X plus 2 here. It's just that you can say it. But I can make you to see that there is X plus 2 here by taking out 2 here in this bracket. If I take out 2 here in this bracket, it's going to multiply this 4 there. I'm going to have 8. I took out 2. It means here I'm left with 2. Plus, I took out 2. It means that here I'm left with X. Minus X plus 2 all squared. Over X plus 2. Now it looks nice here. Because in this term, you will see when we're doing algebra soon, and this term, in this term, there's X plus 2. I can even write this nicely. 2 plus X is the same as X plus 2. Therefore, I can write this as X plus 2. Because 2 plus 5 is equals to 5 plus 2, which is equals to 7. Therefore, 2 plus x is equals to x plus 2. So I can even write this nicely to say this is x plus 2. In my mind, I take out 2 here. If I take out 2 here, what am I left with? X in this term. Here, I'm going to be left with 2. That 2 multiplies this, it becomes 8. I could have put this 8 there. It's one and the same thing. I can put it there. It's one and the same thing. Now, since there's x plus 2 in this term, x plus 2 in this term, x plus 2 in the denominator, I can factorize, or I can take out x plus 2. I take out x plus 2. In this term, I took out 8 plus 2, x plus 2 in this term. What am I going to be left with? In this term, I'm going to be left with 8. You can see that because I took out x plus 2. There's a minus. There's your minus there. I took out x plus 2. There's 2 of them. If I can open 2 brackets, which are x plus 2, and take one of the x plus 2, I'm going to be left with x plus 2. This multiplied by this, it's still that. This multiplied by that, it's still that. Therefore, when you factorize, it means that you can be able to go back to what you had. Therefore, if I have this, then I can go back. This multiplied by that, I'm still getting that. This multiplied by this, I'm still getting that. Therefore, it means that I have factorized on top. Divide by x plus 2. Now, in mathematics, we can only cancel if we multiply. Therefore, this multiplies that, therefore, divided by that. Therefore, it is easy for us to just cancel the 2. But we don't forget that there was an x in that over the equal sign on the left-hand side. Therefore, after this step, obviously here we still have x there. Come down up until there. There's your x is equals to this. Therefore, now we have x is equals to 8 minus x plus 2. Because this cancelled with that. There's your x. This is what is left on the other side. Now,